Video 1.2 An Introduction to Blockchain. In this video, we will cover the following topics. What is blockchain? Why is blockchain needed? How does blockchain work? Uses of blockchain. Put simply, a blockchain is a digital, decentralized, distributed, immutable ledger. But what does this mean? Well, a ledger is simply a record of transactions, such as a book that a company might use to record any of their monetary transactions. Likewise, a blockchain records transactions among users, with each transaction recorded in a block. These blocks are linked together to form a chronological ledger. The words decentralized, distributed, and immutable are the properties that differ a blockchain from a regular ledger. Saying that a blockchain is immutable implies that it cannot be changed. Blocks that have been created and added to a blockchain cannot be deleted or moved around. Data can only be added to a blockchain, not removed. Decentralized refers to the fact that a blockchain is not under the control or administration of a singular entity. Distributed refers to the idea that data is spread and shared between participants, or nodes, in a network. This forms a peer-to-peer system, with peers referring to devices participating in the network, that is near impervious to attack. The resiliency of blockchain is due to peer-to-peer verification. Because all participating devices in a network are able to read the data stored in a blockchain, any attempt to change data would be noticed by all uncompromised devices and prevented. Why do we need blockchain technology? Well, the main advantages that blockchain brings are threefold. Immutability. Perhaps the most obvious advantage that blockchain has is the trustworthiness that it brings due to the immutability of its data. People may not be able to trust third parties to be truthful with their information. Blockchain technology changes that with the immutability of a blockchain. A company could store its data on a blockchain that is viewable to its investors. This would allay any questions that may arise regarding the legitimacy of the data provided to them by the company. Decentralization. Blockchain technology transfers power from third parties to the users. Normally, any transactions of any kind are made through an intermediary system. We are forced to put our trust in these systems, although they could play God with our data and property if they wanted. Blockchain solves this issue by providing users with a trustless medium by which they can conduct transactions. The keyword here is trustless. Because data is decentralized and peer-to-peer verified, users need not put trust in any third party. Each user is their own sovereign. Transparency. Finally, the transparency of the blockchain allows for publicly verifiable information. If a blockchain is public, anyone can see its transaction history. Utilization of this in organizations and governments leads to less corruption and holds these bodies answerable to the public for the information in the blockchain. Additionally, transparency allows for faster transfer of data. While otherwise, requests for data would have to go through a centralized data storage platform, the transparency of blockchain allows for data to be retrieved much quicker. Let us familiarize ourselves with how a block is added to a blockchain. The process starts when a user makes a request for a transaction. This request is then authorized by the nodes on the network. This is done so when a majority of nodes deem the transaction valid. After the transaction has been authorized, some devices compete to mine a block for the transaction. Put simply, miners compete to solve a complex cryptographic problem in order to generate a new block. The miner that completes it first is awarded a reward in the form of cryptocurrency. After a miner solves the problem, other miners confirm the solution and the block is added to the chain. Each block contains a unique code called a hash that is used to identify it. The hash is dependent on the content of the block and is involved in the problem that the miners have to solve. A block contains its content that describes what the block is recording, its own hash, and the hash of the block before it in the chain. This forms a link between blocks in the chain. Because the hash of a block is dependent on its data, any attempt to tamper with the data in a block would change its hash. This would result in a mismatch in hashes, and the blocks following the tampered one would become invalid. The problem that the miners have to solve is the so-called proof of work that blockchain employs. By expending significant computational power to mine a block, it is infeasible for one entity to gain control over a blockchain. Moreover, the peer-to-peer verification system provides a layer of security to a blockchain, as explained previously. To participate in transactions, a user needs a wallet, which is a program that allows users to store cryptocurrencies and assets. A user's wallet has a public and private key, which are cryptographic keys used to encode and decode transaction details. Knowledge of their private key allows a user to make transactions, while knowledge of the public key allows the blockchain network to read and authorize the transaction. Now that we know how blockchain technology works, let us take a look at some of its uses. As we have referred to extensively, blockchain technology can be used by organizations as a trustworthy and transparent system of record. Perhaps the most well-known use of blockchain technology lies in cryptocurrency. Cryptocurrencies, which have taken the world by storm, are digital currencies, transactions with which are recorded on the blockchain. This is an excellent application of blockchain technology as it allows for a form of monetary value that directly integrates with blockchain. With all the benefits of blockchain technology, immutability, and trustworthiness, cryptocurrencies provide an easy way to make secure monetary transfers. Additionally, smart contracts, which we will cover later in the course, provide cryptocurrency users with ways to set autonomous conditions on transactions. Another use of blockchain technology, and the focus of this course, are NFTs. NFTs allow for the secure transfer of digital assets using a blockchain. We will, of course, gain a much deeper understanding of NFTs over the remainder of the course. DeFi is yet another application of blockchain technology. DeFi stands for decentralized finance and refers to financial products and services that work using the blockchain. Users' access to DeFi services are not controlled by any authority, and DeFi services are accessible to all. In traditional financial services, you entrust your money into the hands of entities such as banks and brokers, so you likely do not know how they are handling your money. DeFi is built on transparency. You can see exactly where your money is going. This brings us to the end of this video. In this video, we covered the following topics. What is blockchain? Why is blockchain needed? How does blockchain work? Uses of blockchain. In the next video, we will learn about the evolution of the World Wide Web.